Front claw is the fastest stroke among the 4 first strokes. In the front claw, the exertion of propulsion by the arms is greater than by the legs. Therefore, the phase of swimming movement is divided based on the upper limb movement. First, the period from when the hand enters the water to when the hand starts moving backward is called the entry and catch phase. Next, the period until the hand reaches just below the shoulder is called pull phase. The period from the end of pull phase until the hand comes out of water is called push phase. After that, the period until the hand enters the water again is called recovery phase. The entry and catch phase and recovery phase are defined as non-propulsive phase, and the pull phase and push phase are defined as propulsive phase. Whether the propulsion was exerted or not was only analyzed from swimming motion. In the propulsive phase, the hand moves backward. It is mainly based on idea that the water is pushed backward by the hand, and the reaction force generates the propulsion. However, when the hand moves vertical and lateral direction, there is a possibility that the propulsion is exerted by the effect of unsteady water flow. Therefore, it is necessary to re-examine the propulsion in the Ishii phase by measuring the propulsion considering the unsteady water flow. There is a pressure distribution measurement method as a propulsion measurement that considers the effect of unsteady water flow. Small pressure sensors were attached to the surface on the hand. The hand resultant force is calculated as the pressure difference between the palm and dorsal pressure value. This is because pressure is based on Bernoulli's law that acts from high to low. Propulsion is defined as propulsion direction component of resultant force. The pressure distribution measurement method has been established as an effective method for measuring propulsion. Thus, the purpose of this study was to re-examine the propulsion in the Ishii phase using the pressure distribution measurement. The participants were 12 male swimmers. They performed a 20-meter maximal effort swimming without breathing. In propulsion analysis, 6 pressure sensors were attached on the right hand. In addition, 7 markers were attached to the swimmers, and the actual coordinate value were acquired with motion capture cameras. The hydrodynamic pressure was calculated by subtracting the hydrostatic pressure from the pressure value measured by the pressure sensor. The hand divided into 3 segments based on the 2nd and 5th metacarpophalangeal joints. The resultant force is calculated by the product of pressure difference between the palm and the dorsal and segment areas. The resultant force was divided into 3-dimensional components, and we defined the force in the propulsive direction as propulsion. This graph shows change in the hand propulsion over time. the yellow field area is the Ishii phase. The mean hand proportion in the Ishii phase was 22.4 Newton, and in the propulsive phase, it was 74.1 Newton. The percent EC, which represents the ratio of the hand proportion in the Ishii phase to the hand proportion in the propulsive phase, was 29.1%. From this result, it is considered invalid to define the Ishii phase as the non-propulsive phase. This graph shows the hand velocity in each of three dimensions. First, regarding the velocity in the front-back direction, it can be seen that the hand moves forward in the Ishii phase. In other words, the hand proportion was exerted, even if the hand did not move backward. When you look at the hand velocity in other direction, you can see that the hand moved to right and down direction. Therefore, it is possible that this movement generated the pressure difference between the palm and the dorsal, and contributed to the exertion of hand proportion. The pressure value on the palm increases when the force is exerted to water, and the reaction force is received. In the Ishii phase, it is achieved by moving the hand to right and downward, with the palm on the leading side. The dorsal pressure value generally decreases as the surface flow velocity increases. Therefore, depending on the slope of the hand, the water flow velocity on the dorsal may change. In addition, the slope of the hand determines the direction of the resultant force, and also the magnitude of hand proportion. Therefore, adjusting the slope of the hand is important for exerting higher hand proportion. However, we couldn't quantify the water flow in this study. So, in the future, it is required to investigate the relationship with the pressure value, quantifying the velocity of water flow around the hand. Conclusion: the purpose of this study was to re-examine the proportion in the Ishii phase using the pressure distribution measurement. The Ishii phase was recognized as propulsive phase because the exerted proportion in the Ishii phase was 29.1% to proportion in the pull and push phase. In the future research, it is required to identify techniques that exert higher proportion in the Ishii phase by quantifying the water flow.